Good evening,
Good
sir.
evening, sir.
I asked it first. Help.
I was first.
In your dreams. Hey, that Taruna, that guy took a pen and then wrote something on my
Hello.
white pant.
Hello, can you hear me?
Yeah, we can hear you. White pant. And then I took a highlighter, colored his entire white pant. Now his shirt looks exactly like his pants. Palm the Tarun.
Nitish, I can't hear you there. Hello, can you hear me?
Bro, I know you can hear me. What are you opening, bro? I can see your face flash.
Hello.
We can hear you,
Hello.
Sankal. We can hear you. I think.
Okay, nice.
I can. Good evening, sir.
Yeah, now I can hear you.
Bro. Looks like I was talking to no one.
Guys,
Yeah, you were saying.
Good evening,
Good
sir.
evening, sir.
arrange
Sir,
this
we
thing
are
for you.
going to talk about that. Sir, we are going to talk about that magnetism thing on today in this PTM, sir. We are having it on Sunday.
Neither are my parents.
Going to talk about
That
I think we are
magnetism
going to
chapter,
learn
sir.
magnetism only today.
we'll learn magnetism today.
What the
Sir, who is
subject
Wonderful.
of it?
learning room and who are
Hey, learning
sir,
room is the person who's making the recordings, sir. All the show is the teacher.
yeah, but learning room was not there in all these classes. We got learning room like since when, like
I think all the show is
in
like
the first
in a
classes.
different device. I think he's in a different device, so he can't take a recording.
What is the
Uh,
problem? Tell
One
me, I'll
second,
solve
sir.
any problem.
Give me a minute. Okay. Magnetism, right?
Yes, sir. So we learned
yes, sir.
a lot of stuff in
Yes, sir.
magnetism today. We're almost over in magnetism.
Yeah, but I didn't understand a single thing.
And you didn't come today.
I know, right?
Yes.
They're going too fast.
See my screen? Can you see my screen?
Yes, sir.
We
Yes,
finished
sir.
electromagnets. We finished permanent magnets. We finished comparison. Oh, chapter
Electron
over.
magnets.
Book.
What?
Yes, sir.
Electromagnets. Book is up over. Yes, sir.
Oh my God, these are our
Sir, you taught us all of
expansions.
this.
Yes, sir. Oh, I
More than
remember.
100 slides.
Yes, sir. So I think
No,
my
sir. The
You
favorite
learned
previous maths, sir.
It's just
subject in
physics.
physics. I mean,
It's
Sir,
just
we
so
can't
my
hear you.
physics.
favorite. We can hear him. I can hear him.
Sir, we cannot hear you, sir.
We can.
We
Hey,
can
can you
I'm
hear
not
me?
totally
As
not
audible.
hear you,
Konguvel.
sir.
Can you hear me,
Yes, sir.
Konguvel?
We
We can't
cannot
hear
hear
you,
you,
sir.
sir.
Yes,
I
sir.
can hear, sir.
Even though.
I can hear, sir.
Uncle,
I can
Hi,
hear you,
sir.
Uncle,
sir.
can you
Sir,
hear
your
me?
voice is delaying. Now only we can hear.
Sir, me and Sankar were able to hear, sir. Sir, Konguvel was delayed, I
Uncle,
think.
please refresh.
It's delaying. It's delaying.
Sir, for me, it's okay, sir. Let's
It's
computer
delaying,
crash.
You
that's
can
what.
Hey,
hear me?
Like after he speaks
why
in the
do
way,
you
only he's
still
speaking.
not understand that this was a prank, then, Nitish?
Sir, say hi immediately if you've heard this.
Hi.
Hey, Sankar, shut up. It's not funny, da. Congo is actually delaying. For us,
See, it's coming so late.
for us, it's
He didn't even
immediately.
speak yet.
Wait, I can't hear you also.
He spoke that you didn't hear it or something.
Wrong.
He said hi.
Hey, Kongwe, say hi.
Oh, wait.
Da.
See my screen?
Yes,
Can you see
sir.
my
Hi.
No,
screen?
sir. You
So you
you
just
stopped
Yes,
it,
sir.
sir.
You,
You just stopped it. You stopped it.
Tarun will not join.
No, sir. He won't
No, sir,
join,
he
sir.
won't.
Maybe 30 minutes. He last
No,
30
sir.
minutes. Maybe he'll join.
bro, what's the
Magnetism.
point?
I came last 30 minutes once. I mean, first
Okay,
30
see.
minutes once, not last.
See. Please be quiet because we need to complete this as fast as we can in order to get you out of the
Yes.
subject. Right?
Yeah.
It
Yes,
is quite
sir.
small chapter for you, but it is really a very big chapter in class 11th and 12th, particularly preparing for NEET and JEE. So that is really big there.
Sir.
So magnetism, okay. So magnets actually were discovered long ago.
Sir, can you
From the,
share your screen, sir?
Lodestone.
Can you share
Can
your
you share
screen,
your
sir?
screen?
Is it not share? It's not
So
there.
you stopped it. You stopped
Sir, you stopped it, sir.
that
Stop.
song, sir.
Is it fine?
Get some help.
Yes, sir. Now I can see.
Yes, and now we can see. Well,
Yes,
not
sir.
really, but actually we can.
Magnetism.
So magnetism, like earlier, what happened in long ago in China, they used to the magnets they used to ride the boats, and
Not
basically
China.
before that also there was a shepherd. The
A
story
shepherd.
comes from there. There was a shepherd. Shepherd was
name?
moving with
Yes,
his
sir.
I don't know the
Hey,
name
shut up there.
actually. So shepherd was having a stick, okay, and at the end of the stick there was metal plate. Have you seen that stick of the policeman?
Yes,
Yes,
sir.
sir.
At
The
the end,
battle.
Oh yeah, with the
at the end
Oh,
there is
that
metal
stick
plate.
suddenly got stuck to the wall, and then he dug the wall and saw what it was, and it was a stone, lodestone.
Listen here. So at the end of the stick there was metal plate, and that metal plate got stuck into a kind of stone that was called lodestone at that time. So he was confused why that the stick got stuck with that stone. So later on it was discovered that that kind of stones have got different properties, and that the term was devised from the place at which it happened. That was called magnesia. So from magnesia it became magnetite,
Magnet.
okay, and magnet. From there it come, right? We'll be
Yes,
yes,
doing
sir.
sir.
it
Yes.
fastly. I'll be doing
Why?
this chapter fastly so that you just understand it and you can read the theories from your book. I'll show you how to do the numericals because we need to complete it now. Later on, we'll do it in a detailed manner. So this is just for your exam.
Sir, our physics teacher said that we don't have any numericals from this chapter.
No, we do.
Okay, let us see.
Actually,
I don't know.
That is fine. Now see here,
What-
magnet. What are the properties of magnet? So magnet has got the property that whenever
It
you
attracts to unlike.
whenever you like tie it to a string, whenever you tie it to a string, so what will happen? The north side of the
It
magnet
faces
and the
the
south
north.
side of the magnet will align themselves in the north side direction, north south direction.
Yes, sir.
Understood?
Yes, sir.
They'll align themselves in the north south direction. What will happen? The north part of the magnet will be facing towards the south, and the south part of the magnet will be facing towards all these things, basic things you know.
Yes, sir.
Okay. Two like poles attract each other,
yes, sir.
right? How can you say yes?
Sir, because they do, sir. Because
No, they don't. It's
like
unlike
poles,
poles.
like
It's
poles
unlike
repel.
poles. I didn't say attract,
Yes.
sir. I never said attract.
No,
I was waiting
Repel
for
each
other
other.
guys to
Focus
tell it.
here.
sir.
Like
You
poles
said
repel each other,
repel,
and
right?
unlike poles,
Unlike
I
poles,
said
attract.
unlike poles attract each other,
Ah,
right? This is the
Yes,
basic
sir.
property of magnet. Now see here, one very interesting question. Who will answer this? I'll give him the Einstein
First
badge.
raise hand. First
I
raise
see
hand.
that.
Raise hand, raise hand.
No, da, put up.
Okay, now see.
Okay, that's
No, click done, click
Yeah.
done, click done.
Hey,
This
Oh, yeah,
is
actually,
this is
sad.
okay,
done
yeah.
that.
You have to write then. You have to write then. You type done
Yes,
and then type. You just press the enter. We have material here, okay, and we don't know whether this is magnet or not. And we have this magnet. This is particularly a magnet that we know. This is a magnet, and this is any material. We don't know whether this is magnetic or not.
Is it metal?
So this is property 1. This is property 2. by which property you can definitely define that whether this is a magnet or not. Okay, Nitish is
I
done.
know it.
Wait a
Sir,
minute,
he
wait a
sent
minute.
it beforehand, sir.
No,
Before
I
I
Yes,
told
already
sir.
knew
He
the
exam.
sent
question.
it
I already
before.
knew what the
No,
You
question
didn't
was.
even complete the question,
I
sir.
already knew what the question was, sir.
No, I saw him. I
That's
saw him
wrong.
after completion. I saw him after
No, sir.
completion. I saw that done after
Complete.
completion.
Hey, your thing is delaying. That's what I get a good computer.
I need the reason.
I have
Shall
better
we
computer
start
than
with
this one.
Nitish?
Sir, I'll tell, sir. Yes, sir.
First you tell me. It is property 1 or property 2?
Sir, property 2, sir.
Property
2, 2, 2.
property 2. Okay, how?
Sir, because the material, assuming it's a metal, uh, when the magnet is close by to the shut up. When the magnet is close
What is
by
wrong
to the
answer?
metal, sir, wait, sir.
It is.
No.
When the
1 is the
magnet
correct
is,
answer.
Yes,
yes,
sir.
sir,
That is
asking is
because even magnetic
Proceed.
materials can attract to magnets, but only like
No,
other magnets
only
can
if
repel.
other magnets. Yeah, like other north and north magnets repel.
Like the thing is there, even if it is iron, not a magnet, it will get attracted. So you
Any
cannot test
metal.
any material. Magnetic material cannot be tested with attraction property. They can only be tested with repulsion property. So if it is getting
oh,
attracted,
you
so
asked
you will
that,
turn it up. If it is
Ah,
getting
yes, that.
attracted, you will turn it up. Listen here, listen here. If
Yeah.
this phase 1 is getting
What
attracted
are you
toward
talking? You
magnet,
always
you
say
will
the
turn it
sentence.
up. Now you will face second phase here and first phase here. Even now, if it is getting attracted, that means it is not a magnet. Understood, everyone?
Yes,
I
sir.
thought you asked about magnetic induction, sir, or induction.
This is why you should not answer before the question is complete.
Hey, don't
Right.
like your moral stories and all that. Keep your stories to
Now
yourself.
see here.
It's only
The
a
next
moral,
topic
it's
that
not
we
story.
have
Yes, sir.
I know.
next topic that we have here
Yeah,
is
like
induced magnetism. So, like when an unmagnetized bar AB of magnetic material such as soft iron or steel, generally soft iron or steels, these are the materials that are used for making magnets because they have their own properties. Okay, soft irons and steels have got permanent magnetic properties. They don't lose magnetism easily. Understood? You
Yes,
can
sir.
like remove magnetism from any material by beating it. There are several ways. You can drop
Heating
it
it.
repeatedly,
Heating.
dropping, heating, or putting them into fire. By these 3 ways, you can
What are
remove
what are examples of permanent magnets again?
permanent magnets. Like
Magnesia.
you can make permanent
Lodestone,
magnets.
magnesia,
Soft iron and steel are the materials that are used to make permanent magnets. Okay, we can make these are not the examples of permanent magnets. Now,
the methods to make
Sir, can you say the materials again? Like if it's wrong.
lodestone.
soft iron and steel.
Okay, sir.
So there are 2 kinds of magnet, temporary magnets and permanent magnets. So temporary magnets are those which acquire magnetism when they're kept near a magnet. Okay, when they're kept near a magnet or magnetic field is passing through them, then
Induction.
they'll be acting as a temporary magnet. Otherwise, they have permanent magnet.
Electromagnet. Yes, sir.
Example, if we have a magnet here, and you keep a magnetic material here, so what will happen
So
now?
this side will
Opposite
become
pole
solid.
will develop. Opposite pole will develop. This is called magnetism, induced magnetism. It's got induced in it without touching. Opposite pole will develop. And now, if you keep this apart through some forces, I am not letting it to go.
Sir, so
towards
the
it.
other one is just a metal piece. Other one.
Yeah,
Soft
this was
iron
just a metal piece,
or metal.
soft iron or steel, whatever you can take. So then this north pole creates a south pole here, and any magnet cannot remain with just one pole. If you create one pole, other pole will already be created there. Now what happens? See, can if I ask you, Sankalp, if I cut this, will I get north pole only?
No, sir. You'll have a north and a south.
What will happen
Sir,
after
like-
cutting this? This opposite part will develop itself a north pole, and this opposite
Yes,
part will
sir.
develop itself a south pole.
it's like a mirror.
Even if
Sir.
you cut after this, same thing will happen. North, south, and here, south, north, like this. You cut any n number of
Sir.
times. the south and north condition will already be developed there. Got it?
Yes, sir.
Sir, it's like a lizard
Magnetic
which
pole.
cannot, like, it will always have
It's
a
like a
tail.
mirror, they divide, not a lizard. It's not a lizard.
One more thing.
Lizard
One more
will
thing.
die.
You have the notes now with your book in your book.
Starfish. Yes, sir.
Books you have now for this,
Yes, sir.
because I'm not writing notes.
Even-
If I started
Yes,
writing
sir.
notes each and every point, it will take me 3-4 classes to complete it, and that much time you don't have. So
Yes,
that's
sir.
why I'm not writing the notes. I hope you don't mind that. So I'm
Yes, sir, I
guessing
don't
the
mind.
one
It's
thing
okay,
that you have the book and you're opening that book in front of you and you're reading the lines which I'm explaining.
Hey, this is the wrong chapter.
Sir, 1 second, sir.
It's called induction,
Open
right,
your book.
sir?
Yeah, I'm on induction.
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 So try to see the books, take the referral from there, and hear what I'm teaching here, so that you get it 1-to-1 and you understand every line, and then you can read that. The notes itself is there in the book. Okay? Everyone ready?
Yes, sure.
Yes, sir.
Now we have induction in temporary magnets. The temporary magnets can also have inductions. The same way which I told you. What you have to do, you have to put the magnets in front of a magnetic material, and that creates an opposite pole. And if one pole is created over this particular material, opposite pole will already be developed there due to this.
Yes.
Okay, single monopoles never exist. Monopoles, that means a single poles. Monopoles never exist.
Sir, if it doesn't exist, why did they name it, sir?
Why
It's
did
like
they
that
name your
only.
dad?
They didn't.
Okay, so what happens? There is something called lines of magnetic field. Lines of magnetic field.
Yes,
1 minute.
that's what I understand in school.
Okay. See here, if we place
What
any
did-
magnet,
Yes, sir.
if we place any magnet,
What?
this is any magnet.
Yes, a bar magnet.
There are different types of magnet. This is a bar magnet, let us say, right?
Yes, sir.
What is happening here? What is happening here? If we consider this as North Pole and this as South Pole, so there are magnetic field which emerge from now North Pole, and they try to find the nearest South Pole. They emerge from North Pole and then they try to find the nearest South Pole. Okay, nearest
sir.
South Pole. If you place any South Pole here, so like field will go from here to here.
Not from that south. So what will happen to that
But
south, sir?
I'm just taking this South Pole, that is the opposite pole of it.
So what will
Nearby.
happen
I'm
to the
realizing-
other South Pole, sir? What will happen to the other
It's my
South
question. It's my
Few-
question, sir.
Few magnetic field may go there. There are infinite number of magnet. It is not like this. There are so
Yes,
many
sir.
magnetic fields that you cannot imagine. You
It's like
cannot
a
imagine.
wave.
I'm just drawing
Infinity.
less number so that this diagram does not get confusion.
Sir, so basically one magnetic ray is like 10 to the power negative infinity.
Ayo.
Yes, sir.
Hey, when will you stop using
Oh
infinity,
my
da?
god.
Why?
Infinity is not a number, da.
Okay, see here. So magnetic field, point number 1. If you are talking external to the magnet, internally what happens? Magnetic field travels from south to north.
Yes, sir.
From south
All
to
magnetic
north.
fields, sir.
Yeah, all magnetic field.
Sir,
All
like
of
what
this
exactly is magnetic
circle,
field, sir?
and then take a loop like this.
Place
Okay, they
around the
form a
magnet.
closed loop. They form a closed loop. What did you ask, Kongwe?
What exactly is like a magnetic field?
Magnetic field is a kind of influence. Is a kind of influence around the magnet, and based on these influence, we have drawn an imaginary line.
Yes, sir.
Why
What
we
does it
have drawn like
influence?
this? That's what I'm telling you. Why this line is there, I'll tell you. Okay, why this line is there? So magnetic field lines is like, what happens if you will, what you'll do now, you just place a magnet, you just take a paper, place a magnet below it, the magnet is below it, running horizontally like this. Okay.
Yes,
Oh, yeah, and then you take the powdered magnet, whatever that is.
sir.
And then you take iron
I am
filings.
filing. Iron filings.
Iron filings. If you take iron filings, now what will happen? They will align themselves in this magnetic field.
Oh, okay,
They will
sir.
align themselves in this magnetic field. The magnetic field are those imaginary lines along which you get to experience that what exactly magnetism is. Understood? For example,
Yes,
current
sir.
travels in the conductor. Can you see that?
No,
No,
sir.
sir.
Yes, yes, sir.
But
I can see it.
You
current, but
can't.
current requires a particular conductor to travel. Magnetic field don't require
Oh,
that
I
particular
know.
conductor to travel.
Yes,
Sir,
sir.
it
They
needs
just
This
go
is
iron
and
the kind of
filings,
ask.
right,
same
sir?
influence. Same kind of
They
influence is there.
iron
It's not
filings is
like
just to
you
show
can't
us,
see it. You can't see the fields, sir.
Iron
It's
filings
there
was
though.
to just to show that along that particular line you are getting the magnetic field. Okay, and magnetic field you are
Okay.
getting the iron filings get attracted or deflected from the magnetic field.
Uh, I
Understood?
attract. Oh yeah.
You don't have to imagine much exactly. With due process, you will learn exactly about magnetic field. You just imagine that this is a kind of influence. For example, if I can say that, if there is some kind of you see now, you see if you blow up a agarbatti, that incense stick,
Blue. Okay.
you
Yes,
see
sir.
wavy lines there, wavy lines there.
Yes, sir.
Yes,
Smoke
sir.
Yes,
or
sir.
smoke.
It is a kind of same thing, but the thing is that you cannot see the imaginary lines. That is the
So it's
influence
like
lines.
Yes, sir.
If you take your nose, if you take your nose towards that wavy lines, that vapor lines, so you will get to hear sorry, smell the same, smell that incense of the stick, isn't it?
yes, sir.
Yes, sir.
But if you stand apart from it and that smoke does not come to your nose, then you won't be able to get anything,
Yes, sir.
smell anything.
Understand.
So
Yes,
in
sir.
order to get the influence of that particular incense stick, you take your nose towards that lines. Similarly, to get the influence of magnet, you have to take the magnetic material in the influence of that magnetic lines.
So again, like, what does it influence? Like one word answer. Is there anything?
Told you, na, there are different influences. You can get force in this line. You can get
Like,
magnetic force. There are
what
magnetic
can
force
I
in
write
this
as a
line.
definition, sir? Like for magnetic field.
Magnetic field lines. Magnetic field lines is a continuous curve that is imaginary, and like one more thing is the tangent. The tangent to give that lines gives the direction. See, Kongwe, what you are asking, I understand that is the depth of something. Okay, you want to understand what exactly is magnetic field lines, but the thing is that I want to explain it to you that you cannot understand magnetic field lines at this point of time. Okay, you
Yes,
have to
sir.
believe that
That's
that is
okay.
there. You're not believing me. You are still
I
asking,
don't.
and that is good thing. No, that is good thing. That is good thing. Even I was the same way. I did not used to understand what is exactly virtual image. If it is virtual, then why we are studying that? If it is not being formed, we are told now that virtual images are not
Yes,
formed on the
sir.
screen. You must have studied that. So I used to
Yes,
go to
sir.
ask to the teacher and ask him again and again, if it
It
is
was
not
eighth
being
grade
formed, how
nightmare.
can we
It was
study it?
such a hard chapter.
How can we
Yes, sir.
study
Oh,
it?
what?
Getting my point.
Yes,
Yes,
So
sir.
the
sir.
same way, but in due course of time, you will understand that what is the importance of virtual image, what is the importance of real image, what is the exact. It doesn't matter. The thing is that you don't know that magnetic field also provides force.
Yes,
Okay,
sir.
Yes,
and
sir.
that force will act based on these wavy lines. The direction of force we will calculate with the direction of magnetic field lines. The amount of force will calculate with the distance from the magnetic field lines it is there from the exact magnet. So all these are important, and there the significance lies there that you are asking basically. So I cannot explain
Yes,
it to you
sir.
because these terms are not there in your syllabus. You'll learn these things and then you'll get to know that exactly what is the use of magnetic field lines. Understood?
Yes, sir.
So we got a
Just
portions for
understand.
the physics.
Pardon?
Nothing, sir. Nothing. You can continue.
Okay.
Sir,
So there in the
so,
book, you'll see the
sir, so
definition
you
of
know,
magnetic field line.
excuse me, sir.
Hmm.
Sir, so we like say we have some iron in our body, right, sir? Like some iron
Upon
vitamins we have.
that.
So like, does a very strong magnet stick to our
Pull your
body,
body
sir?
apart.
iron that is present in your body, do you know how much that is?
I know it's like very point. It's like that, sir. Can a very strong magnet like attract it, sir?
No, no idea. That is really small. That is very
Maybe
small.
It's
Very,
dissolved.
very, 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 very,
Like it's
very
how
small.
can I say it?
It's
You cannot
Dissolved in
imagine that
blood,
much.
hemoglobin, like that.
So all of you see here that definition of magnetic field lines, that are imaginary curves drawn around the magnetic field. They are closed curve. You just saw that I drew a closed curve. The curve starts from North Pole. They take a curve and enter the South Pole, and inside the magnet they complete the curve. Okay, so they are complete curve. One more thing, the tangent at any point gives the direction of that magnetic field lines. The tangent at any point gives the direction. So that's why two magnetic field lines cannot cross each other, because at this particular point you'll be having two directions. See, this line is showing this direction and this line is showing this direction.
Yes.
So you cannot have two
sir,
directions at
do the
one.
lines, sir, can I put the arrow marks in any direction for like one side?
No, it will always go from north to south only, I think.
Yes,
Okay.
already drawn from north
Always
to
go
south.
to
If not,
north. But in the bottom,
yeah,
it should go
north to
from
externally
south.
south to
always
north,
north to
right?
south.
No.
Externally always
Bruh,
north to south. Internally
bruh, in
always
the
south to
bottom
north.
also it will go from north to south there.
Yeah, even here also.
Okay.
Externally
Okay, sir.
everywhere, north to south. Internally south to north. Okay.
Oh,
Internally,
internally is like south
Properties.
to north. Okay.
Internally, like
Properties
inside.
of line. You see that properties topic. Properties of line. They are closed and continuous. Outside the magnet, they are directed from north to south. Inside the magnet, they are south to north. The tangent at any point gives the direction,
so
and they never
basic,
intersect each other.
so basically these magnetic lines are like an oval if you connect the inside lines also, sir.
Kind of,
This
not
come up,
oval. All of them are not oval. There are different lines. There are different lines.
Okay, sir.
Different shapes for different lines. If you draw for very big one, take very larger distances. They have different shapes. Elliptical also, oval also,
So that
maybe
means
anything.
each line will always come back to north. Like it comes
Yeah.
starts at north and come back to north. Like it's a
Yeah, that's why it is said in the properties. In that properties definition, you see there are 4 properties. They'll ask you in this exam.
close and
What are the
continuous.
properties of
Okay.
magnetic field lines? It is a very important topic. So I told you what are the
I
important
highlighted.
properties. You highlight
Close
this.
and
What are the
continuous.
properties? Properties are
Close and
closed
and
continuous curve.
continuous.
Second, tangent at any
Outside.
point gives direction. Third, outside they travel north to south, inside south to north. And fourth one is that they never intersect. Why they never intersect? Because tangent gives the direction. So if they intersect at one point, we'll be having two directions. That is not possible. Understood,
Yes,
everyone
sir.
till here?
Yes, sir.
I'm
Yes,
going
sir.
Yes,
really
sir.
fast. If you have doubt in any topic, just tell me. And if you're understanding it, then that means you're brilliant students.
So it's easy, sir. This chapter. It's just
Easy.
Sir,
One
is
more
the
thing.
tangent part given in our book?
yes, it's given. The
I
tangent
think
Yeah,
at
it
any
is
given
point.
given
that.
there. Today it's
The
page
direction
number
of magnetic field line.
220. Page
No,
number
no, no.
225.
I didn't ask. I
I
didn't
don't
ask.
know your book. I don't know your book.
So
I have
it's
not
that.
seen that.
It's that,
Okay,
sir.
sir.
It's
Just
that.
ask.
It should be there. I'm not saying anything extra. Okay. Next point. Fifth point. Fifth point. You must have seen that at this particular point and at this particular point, in position 1, there are more number of field lines. So whenever you will see that there are more number of field lines, that means there will be a pole nearby. For example, if you have an ice cream shop nearby, you will see lots of boys,
Children.
lots of
Oh.
children
Yes,
nearby,
sir.
isn't it? So you can guess that
Yes,
there is
sir.
some shop nearby, toy shop or ice cream shop or something like that is there, isn't it?
Or
So
white
similarly,
one.
if you
Yes.
see
Yes,
more
sir.
number of magnetic field lines, that means there is any pole. There can be any pole. North pole also can be there, and south pole also can be there.
Yes.
Understood?
Sir,
But it's something like
I don't
I'm
get it.
going this way. Okay. See
It's
here,
like
see here.
if
I am going this way. I am going this way, right?
Yes,
Listen
sir.
here. I am going this way, and if I see that I was here, I was here first. I was here first. Okay, exactly here.
So
I
you
saw
take a
10
circle and come back.
number of field lines. I saw 10 number of field lines coming towards me. I moved from here to here. Now I'm seeing 20 number of field lines from here coming towards me. Can you tell me on which side of mine North Pole exists?
So that side.
sir,
Sir,
North Pole exits to the frontwards, sir, to your front, like to your front.
To your
Exactly
side.
this side. Why?
This
Why?
Yeah, I mean
Why?
that side.
See, first of all, if I was moving this side, the number of field lines was increasing. That means there was some kind of pole there, either north or south. But the field were coming towards me. That means there must be some kind of north pole. That was from where the lines were existing. Are you getting my point?
Yes,
From the
sir.
north pole, the lines were taking the exit. So that's why they were coming towards me. If the thing was that I was moving this side and from my back the lines were coming, from my back the lines were coming, then what would have
Yes,
happened?
sir.
The pole
Same.
is the back
The
side of
North
it.
Pole.
Pole is
The North
behind
Pole
you.
is in the other side.
Geographical south. Sir,
Then what would
it's
have happened?
behind you.
That means from my
Behind
back
you.
side, the pole is coming and it is going in the forward direction. So poles in the external environment, unless and until I'm standing inside a magnet, I'm standing outside the magnet. So magnetic field, if I follow the pattern of magnetic field line, where will I end? If I follow magnetic field line, where will I end?
You
Pole.
take a
So
North
round
Pole.
around the
North
world
Pole.
and come back.
In the
So
North
no,
Pole.
I'll
you'll
end
end in
at
South Pole.
I'll end at
South Pole, da. Things
South
move
Pole.
towards South Pole. So like he'll go to.
I'll
They'll
end at
carry
South
him to
Pole.
South Pole.
See here in the screen. If I start walking, I see that field lines are going this way, this way, this way, this way, this way. Then I'll end at South Pole, na?
Yeah,
Isn't it?
like I don't.
Geographical
Sir,
north.
but
Go on. Go on, go on.
Sankalp thinking for once.
sir, like,
Okay, stop.
okay.
Don't
Will
think
you-
that your question is good or not. You just go on. If you have doubt,
No,
here
sir,
is
You
the
no,
were
answer.
sir.
demotivated.
No, sir. I just don't get it, sir. Like, how is it possible? Like, sir, you said there are like infinite number of magnetic lines, and everywhere there are magnetic lines, right? So then, how can you say over here there are less and over there are more?
See,
It's not more or
at the
less, it's
post,
stronger.
see, let us say that 10 field lines are coming out from here. Let us say that 10 field lines. Okay, I'll draw it again. Let us say that 10 field lines are coming out from here. This is a magnet and 10 field lines are coming out from here. So how will 10 field lines come out? See, one field line will go from here to here. One will go from here to here. One will go from here to here. Take the bigger
You
path.
just say 6, sir.
One will go from here to here. One will go from here to here.
I think two
One
is
will
enough.
take the longer path from the above. It will come and then it will join here. How much it is? 1, 2, 3, 4, 5, 6. Then one will take one more bigger path. It will cover that and then it will come back here. 7,
And then Ditish,
8,
smart guy, will go as a short way.
9, and the 10th one.
And then one won't keep.
Can you see there are more field lines at this place and at this
Yes,
place?
sir. Yes, sir.
Now you understood.
So the equal,
Sir, I understand what
Now
he's
you
asking. He's telling that the infinity lines, so like everywhere it should be like completely like it should be
Same, right,
completely
sir?
filled,
Because
right,
Done.
sir?
yeah,
filled,
like
right?
how can you measure them?
It's
cannot
stronger.
measure them
heat,
exactly. We are not measuring them exactly.
So it's the
Strength,
intensity.
strength you have to count. The
Intensity.
strength of the
See.
yeah, intensity.
You are walking. Okay, you are walking, and in the path you get to know that there is a child school nearby. There is a play school, and that is the out time. They just ended the school time. So what will you see? Infinite number of students getting out from the gate, running here and there. Can you count them?
Almost, yes.
School. Yes, sir.
Can you
Popular
count
school.
them? Like if a school has 1,000 students, so can you count them? How much were there exactly?
No, sir.
No, sir.
But you can say that now there should be a school nearby because there are small children and they are wearing school uniforms. So there must be a school in nearby.
What if
And
they
then
come in?
these
Yes,
students scatter like everything. These students can go to 10 kilometers away at their home, or just one student can be nearby to the school also. So they scatter
Can
away,
live at the school. Yes, sir.
isn't it?
Nitish.
Yes,
in the
sir,
same
but
way.
if but if the number is infinite, it should go like everywhere. It should fill every single atom. Like it
Exactly.
should
So
go
these
like
field lines
everywhere.
does not stop here. One field line will be covering the infinite distance. It may cover the universe and then come back here.
So, but it's
This
weak.
also may can
Weak.
happen. You are
It'll be very
underestimating
weak.
this magnet. That
So
will
it'll
be
be
very weak.
very weak, sir.
Okay.
It
If
is
this is a school, let us say this is a school, and it is the end time of the school, and this is the city. So number of students are coming out from here. One will go here, one will go here, one will go here, one will go here, one will remain here, one will go here, one like that. This will happen now. But at the end time of the school, all will be there at one place only. This is what I mean. Got it or not?
Okay. Yes, sir. Yes, sir.
So they will go everywhere. I have just drawn this much because I cannot draw more than this.
Sankalp.
Yes.
Infinity is not a number. Don't even try to
It's
calculate with it.
expression, right? It's an expression.
Exactly.
I know.
I know.
Like, don't even try to
Okay, I know.
If
calculate
the
or
It's
lines,
make
And a big
logic
you
with
know
it.
number.
what thing? If the lines, if the lines
Yes,
are
sir.
parallel like this, if the magnetic field lines at some place you see like this, see you will
Get
say
Earth.
that, sir, how can we get then these straight lines? How can we get these straight
So
lines?
it connects
So
the
the thing is
Earth's
that when
magnetic
you'll be at
field.
infinity now, when you'll be at very far distance standing at some place here with the magnet, any magnet, so
The
you'll get to know
magnetic
that
fields
this
would
is
be at
a straight
moon.
line.
No, it'll be at the
This will
north
be a
and
straight
south
line.
pole, north or
So
south.
equidistance, they are equidistance, they are equal in magnitude. So these lines are called uniform magnetic field lines. Uniform magnetic field lines. Okay. And if they are not equidistant, something like this is there, there are more lines at this place, and then like this.
So
They're not
they'll go to
equidistant.
the
Even if they are
Earth's
Sir,
same.
I
south
have
pole as
just
So
well.
one
all
small doubt. Can there be a
yeah.
finite amount of magnetic field lines in a magnet? Or is it just always infinity?
See,
Hey,
basically we
you
cannot
don't.
count the exact number of field lines in a magnet. So we cannot comment on that.
It's big.
Okay,
That's it.
sir.
Just gets
Okay.
weaker
Now,
So
more and more
much.
with part.
Sir, it's not infinite, but it's uncountable. Is it like that?
you use the word infinite. We have never reached the term infinite. In class 11th, infinity is not desirable answer. You will work to remove that infinity part from your answer if you are in class 11. So these things you'll get to know. Don't work upon
Hopefully,
that
Sankalp
much,
goes to
because
class 11.
when you will get distracted with the exact topic, then some distraction will occur. Okay. Now see here,
Yes, sir.
we'll be talking about Earth's magnetism. Even Earth has got its own magnetism.
Yes, sir.
See, let us say this is the Earth. So we all know that Earth is inclined, not straight. Right? Earth is not
Yes, sir.
straight. Right? They are inclined at some angle to the vertical. Right? Yeah.
That's the axis. It's actual axis.
Yeah. So this is the magnetic meridian. This is called the magnetic meridian. Magnetic meridian. What is magnetic meridian? So this is magnetic
The north.
south and this is
Shh,
magnetic
shh, shh,
north.
shh.
Okay, see here everybody, listen here carefully. And this is geographical north and this is geographical south. So where geographical
Inverse.
north is there, near about it, this is called the angle of declination. So near about it, magnetic south will be there. And where
Angle of
where
what? Angle of what?
declination. How much it is declined.
Okay.
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 So where geographical south will be there will be magnetic north. So see, sir, how we and why we did this? Why we didn't take the magnetic north as geographical north and magnetic south as geographical south? The thing was that
Sir, it's
earlier when
because
sailors used to travel,
geography teachers didn't agree with math
Hey,
teachers.
stop making those. Sir, can you teach what you said once again, sir?
Who?
My
Sankalp, who?
battery ran out.
I know that.
Sir,
Stop it.
Ask.
It's been
can
so
you
old.
teach what you
okay,
said again,
see
sir?
here,
Because
see here,
my
see here.
computer ran out of battery.
Carefully, please. The thing was that earlier when sailors used to travel, so they used to take the compass. You remember? You must have seen
Yes,
that.
sir.
Yes, sir.
Sailors used to take the compass. So compass used to show. The thing was that the top part of the compass used to have the north pole of the magnet and the south part of the compass used to have the south pole of the magnet. So north pole will
Yes,
point
sir.
where? The south pole, isn't it? North pole
Yes, sir.
will point where? Towards the south.
Yes, sir.
So what used to happen? The north pole of the compass was to point towards the south pole. That was at the top, and
So
they
then
used to
again
say,
to the
okay, that
geography.
is the north, and they used to say, okay, that
But
is the north.
why didn't they just name north as south and south as north, sir? That would
That'll be stupid, rather than you can't say unlike poles are repel each other. I mean,
See,
at
see,
each.
see.
Shankar,
For example,
people
I'm
like you
telling
don't
you,
even
see.
come into these matters, right? The smart people only are hired to do all this.
See,
That's a
see.
little bit rude, Rob.
Let us say that this is Pacific Ocean. Let us say that this is Pacific Ocean somewhere here, and Christopher Columbus was traveling, and he saw his compass. What happened? His compass was showing the North Pole this side, North Pole this side, and South Pole this side. Okay. So by seeing this, he said that, okay, sir, this is the north and this should be the eastern. Okay, we'll row towards the east to get. Okay, we'll row towards the west to get towards the US. Okay, so this is what they said. But the thing was that magnetic field lines were coming out from your magnetic north and magnetic south. Magnetic field lines were there from magnetic north and magnetic south. How they were going? So they were going like this. See, from magnetic north, the magnetic field lines used to arise and they end towards the magnetic
1 second,
south.
sir. I'll use the
south,
Yes.
magnetic south.
This.
Oh, okay. Yeah, yes, sir. I got it, sir. I got it. I
Understood?
understand. Yes, sir.
Like this. So even if it is magnet there, so there must be some magnetic field lines also, no? So they used to arise and they used to end it up like this. These
Yes,
are
sir.
there. These are there. And because of this only, we could use the compass everywhere on the earth. If you don't have any magnet nearby, na, so what your compass will show, your compass will point, align towards the direction of magnetic field lines. Okay.
Yes,
For
sir.
example, let us say this is the magnetic field line passing nearby me, the Earth's magnetic field, because I don't have any magnet in this room or nearby. So if I place the compass, this my finger is pointing towards the north part of the compass. So this magnetic field line, let us say, is going from here to here. That means, like, this is my right hand where I'm wearing that bangle. So this is my right hand. Now tell me where the north is, where the south is. If magnetic field line from here to here.
Yes, sir. Now, what did you ask,
Where
sir?
will be the north? If magnetic field
That
lines is
side,
going
that
from
side, the
here
other
to
side.
here,
The opposite side
this
is
part will be
north,
what?
sir.
This part will be what?
Geographical north.
North.
Geog
No, north.
so
It'll be
physics
north.
in physics it's north, but
North, sir. That's it. North.
We are talking about physics only. You tell me whether this is north or south.
North.
north, sir.
Why?
Sir, because the rays are coming from, so I mean the magnetic lines are coming from that side.
Always come from north.
So that will be north. This part will be north, right? So what happened? So these magnetic field lines were used to denote the direction of the movement, because the magnetic field lines used to get aligned along this. Okay, and where they used to point, we used to say that is the north or that is the south. Okay, so that is the magnetic field of lines. And now you say, sir, is there a magnet rod between the earth that much huge, so that is producing this much amount of magnetic field lines?
On the
No.
axis.
So there is no such rod. Thing is that there is hot iron core in between. That is the theory. We don't know the exact thing inside. So hot iron core in between. Okay, so that hot iron core have ions, and due to those movement of ions, we get magnetic fields.
Yes, sir.
Yes, sir. So
Just
compass
wait for 4
shows
minutes.
the magnetic north and magnetic south, not the geographic north and geographic south.
Yeah, that is one more thing. They show the magnetic north and magnetic south, not the geographical north and geographic south. You know, in class 12th, you'll know how to calculate this magnetic declination and how to steer your boat exactly. And they used to know this calculation. Like, okay, this is the angle of declination. My compass should be showing this, and I have to go towards the north. So I'll be storing in this particular direction my steering should be done so that I get to the exact north. Understood?
Who found all of this?
Yes.
That is, physics is all relatable. That's why I told you now.
Sir, one doubt, sir.
The
So
China
you've
guide.
written geographical north and magnetic south on the top. Is it correct or
Geographical
so
north
like
is what we know, and according to that, we have magnetic south.
sir on opposite sides, sir? Like opposite sides of Earth, like literally.
Is magnetic south and geographical, what is that?
North.
Magnetic south, magnetic north and geographical south. It's correct.
Oh, okay, sir.
Should
For confusion, right? For only for sailors, we don't need to learn geography and all that.
you have
For
a
this,
freely
we need to.
suspended magnet at your home, and you don't have
Yes,
any
sir.
other magnet nearby, so it will align itself in the magnetic Earth's magnetic north-south direction.
Sir, but Earth's magnetic field is like very weak, right? So will instead
No, it's
attracted
quite
to that.
strong. Not very weak. Not very weak. You cannot say very
So,
weak.
so I
It
should say
is.
weak.
You may say
Hey,
weak.
Nitish,
Like
it's
you
actually
cannot
No,
have
very
resistance.
strong.
No,
It's
that's
actually very
not
strong.
just
ma'am
not.
said weak. No.
It is not that much
You just
weak,
can't
but
feel it. You just can't feel it.
How
you
can I
cannot
feel
feel
it? I
it.
can't feel a
Strong.
normal magnet.
It's because you're so
But
far
even
away
if you
from the
place
core
a
of the
small
Earth.
magnet, even if you
I
place a
can't
very
feel at
small
all.
magnet hanging, even if you place a very small magnet hanging, it will align itself in that direction. That
Sir,
means
but
they can
shouldn't
feel
it
it.
align to the magnets or metals I have in my home, sir, instead of the that thing?
No,
So
you shouldn't have anything nearby. That's the thing.
I don't even know a place where there's nothing there.
It
Rent a
is a
football
theory.
turf
It
and
is
then
somewhat proved
Where
also. It is
put it in the
somewhat
middle.
proved also.
there's light. There's
See,
what's it?
it is somewhat proved also. If you place a magnet inside the Earth's surface, few meters in deep inside the Earth's surface, okay. So what will happen? That means you're going
Yes, sir,
towards
it's
the
given in a
exact
book.
magnet of the Earth. You'll move towards the exact magnet. Let us say this is the exact magnetic part of the Earth. So if you place somewhat meter deep, so here will be more magnetic field than here. So if you place any rod
Yes, sir.
keeping in the direction of north and south and this is
Yes,
north.
sir.
So what will happen? This will get magnetized. Okay, this will get magnetized. The below part should be south and upper part should be north because
But it'll
it will
take
be
few
induction.
hours, no,
Not
sir.
for, yeah, it will take
4 meters,
lot
sir.
of
What do you
time.
mean?
Lot of time.
How much
Genuinely
time
don't know who
will
was
it
so
take?
jobless to find all this.
Pardon?
Hey, what do you mean? They
Sir,
got
how,
Nobel Prize and everything for finding all this.
sir, how
Okay,
It will
much
take a
sir.
lot
time
of
will
time.
it take for one magnetic
Lot of time.
field line to, sir?
Two.
Yes, he's
Sir, sir, I'm asking that how much time will it take for one line, magnetic field line to reach from north to south, sir?
a snap, a blink of an eye, what a
It's
fraction of a
like
Thing is
second.
almost
that
the speed
they
of
don't
light.
travel.
It's a radar.
See, they don't. You know what happens in a conductor? If we say that we have a battery here, a switch here, and a bulb here, okay. So if we just touch the switch, in what time does this bulb generate the
A
electricity?
blink.
It
A,
Is
will,
that
sir,
a
what
millisecond. A nanosecond.
you will say that, sir? That much speed the electron is, it start traveling from this battery, and then they travel here, and then they travel, and then they,
There's
even
so much
now this
pressure in the
won't
battery and
generate
everything this goes.
no.
And then explode in
Even
the
now
field.
they won't generate the electricity. Now if the circuit is complete and then the electron will reach here, then they will generate the electricity. The thing is that everywhere the electron is there, it is already there everywhere. So if you just touch it, the battery pushes this electron pushes this electron, this electron pushes this electron, and such that the flow start at that particular instant only. Understood? It is not that one electron is traveling the whole way. The lines are already there. They are not arranged. They are not arranged.
okay,
You'll just connect
Yes.
them. They'll get arranged.
okay.
It's like us all in class and then ma'am comes, you all rush to our benches.
Um,
Something like that. Nice relation, Kongwe.
it's just we are 99.9% slower than that.
I know. We should learn from electrons.
So
Okay,
places
there is
where the
no harm
magnetic medium
adding it.
becomes vertical are called magnetic
Okay,
poles.
okay.
Niti.
What happens here? At the
Enough,
poles,
enough.
at the magnetic south and magnetic north. So magnetic poles, the compass becomes vertical because it has to direct downwards now.
Yet,
It
It
has
goes
to
yes,
to
direct
sir.
eastward.
downwards. Like for example, if the magnetic field lines are coming from here to here, so at this particular point, the magnetic poles will be like this way. The compass will be this way. At this point, compass will be this way. But at the pole, if you're standing at the pole, the compass will be down, pointing vertically downwards inside the earth because the magnetic field lines are getting in the earth's surface,
It
right?
will like fidget.
Similarly,
It'll spin so fast. Like
yeah, at this pole,
it'll go
yeah, exactly.
crazy. Become like something.
Okay. Now we'll see the different types of poles, magnetic field lines. If we can draw this, this is north pole, this is south pole.
It
One will
connects, sir.
draw this is north pole, this is north pole,
It
and for
repulse,
south pole, south pole, south pole,
repel.
south pole. And
Same
what
thing,
else we can
sir.
do? Okay, let us see till here only. So north pole and south pole, all the fields will come and enter here, like this.
Yes,
Sir,
sir.
when it
Because it
comes to a
always moves
South
from
Pole,
north to south. Sir, if I'm not wrong, a bar magnet attracts itself towards itself, right?
This I have not studied.
sir,
No,
like
sir,
this
like
magnet, sir, the magnet I have in my hand right.
How can a magnet attract itself? See, north pole and north pole. From here, the field will emerge, and from here it will emerge. But they won't meet. They won't. They will just get aparted.
I know, sir.
They will
Like I'm,
just get
I'm talking about like one bar magnet is there. If the magnetic field moves from south to north, it's basically attracting itself to itself, right?
No, you cannot say like that. You
I
can
have
say, but
strong.
that is, you can feel like that, but you cannot say like that. Here it will be like this, same way, but the arrows will change.
Yes, sir.
It will be towards it.
I have two strong
In exam,
magnets,
you have
sir.
this question they may ask. So you have to like determine the arrow. Always draw the arrow. If you forget to draw the arrow, half number will be deducted.
Yes, sir.
So I have a strong magnet with me, sir.
And you're
My hand right now. It's
Who?
I can't push it together. Me.
Asked.
Asked.
we'll be keeping till
Oh,
here for today. We'll be keeping till here for today.
Yes,
I
sir.
think one more class is required. So you talk to the
it's 8
administration for
minutes,
that.
sir.
Sir, we have two more classes, sir.
This
What
We
about
have two more
revision, sir?
classes.
we can
I don't
complete
know.
this in the main class also. Now we can complete this in the main class also.
Yes, sir.
So I hope
So
you
what
We
on
like the
have
session.
Saturday,
one.
sir?
Understood everything? What I taught?
Yes,
Yes,
sir.
sir.
So today's assignment, will
Yes,
we
sir.
have it on this chapter, sir?
That I cannot create. Assignments I don't create. That depends on the teacher.
Yes, sir.
So you are the teacher.
Solve the questions from your book now. You
Yeah.
solve the questions from your book. If
Yes,
you
sir.
want, we'll
So many
solve
Yes,
some
sir.
questions.
questions.
You solve the questions and we'll discuss
But
in the
we
next
don't
class.
have
Probably we have
any
the class on Monday.
numericals.
Okay, numericals.
No
Even I can see
numerical.
that we don't have numericals here.
Sir, we have to do electromagnets. That's left.
Electromagnets we'll do
Electromagnets
in the
I
next
finished in
class.
school, sir.
Okay, sir.
We'll do in the next class.
Yes,
Right?
sir.
I tried to.
Okay.
I talked to the administration for you,
Yes, sir.
and
Thank you, sir.
I got this. Okay.
You're well. I mean,
Okay
thank you,
then.
sir.
Any doubts?
No, sir.
No, sir.
No, sir.
Okay then. Bye.
Thank
You,
you,
sir.
sir.
Bye,
Bye,
sir.
sir.
Bye, sir.